Moving on to another type of inequality, we have here a situation with a double-ended inequality. You can see there's one sort of inequality there, minus 9 is less than 3 minus 4x, and there's also a second inequality that uses still the same central bit. It's 3 minus 4x is less than or equal to 1. And you still have your criteria defining what x could possibly be. In this example, it can be a real number, so any number, and the graph will involve showing it with an arrow. So let's go through this. The key thing is you split it up into two separate parts. So you split it into the first inequality. So here we've got minus 9 is less than 3 minus 4x. And separately, we're going to do 3 minus 4x. So I'm repeating that central algebraic expression, and that's less than or equal to 1. And we're going to solve them separately. So working our way through. Now, when I'm looking straight away, I'm looking at this, I'm seeing x is a negative. Now, I don't want x to be negative. I don't want minus x. I want it to be positive at my end. So I'm actually gonna move it effectively to the left-hand side. I'm going to add 4x to both sides. And I'm going to add 9 to both sides, and then finally I'm going to divide by 4 both sides. So when I divide 12 by 4, I get the answer 3. So x is less than 3. Nice and easy. I haven't had to deal with negatives. I haven't had to change the direction of inequality and all that sort of carry on. I've made my life a lot easier. Same thing here. I don't want 4x to be negative, so I'm going to add 4x to both sides. I'm going to take away 1 from both sides. And I'm going to divide by 4. So 2 divided by 4 is a half. So I now have x is less than 3, and x, looking at this backwards, x is greater than or equal to a half. Now, just very quickly, when we're looking at inequalities, this idea of a double-ended inequality, it is always the case that the inequalities will point to the left. You'll have the lower value on the left-hand side and the higher value on the right-hand side, and the inequalities will always point in the direction towards the left-hand side. You'll never have any other situation. So in this instance, the lower value is a half, lower boundary is a half, and the upper value boundary is 3. So effectively, I'm going to take the right-hand inequality that I've come up with as my lower boundary, and what I have here on the left is my upper boundary. I've rewritten it with x in the middle, and so x is greater than or equal to a half and less than 3. Now, just before I actually sort of solve that, just very quickly, if we think about the number line, if we think about the idea of what's going on with this, the first one here, okay, x is less than 3, and it's a real number. So if 3 was here, then I'd have a situation where I'd have an empty dot, an arrow pointing down. That represents being less than 3, but not actually equal to 3. All values going down beyond and below 0. Then the second one I have here, which is where x is greater than or equal to a half. Well, I'd start at a half. Now it would be a filled in dot, and it'd be greater than to be an arrow pointing towards the right. So the idea of our final sort of solution here, okay, is it's a combination of both of them. And what we would do is we would represent these two arrows combined together. So my lower boundary is a half. I'm doing this below. You could do it above. I just don't have any room. The lower value is a half. The upper boundary is 3, but it can't be 3. And then I have a line. There's no arrows now. It's simply a closed dot, a line, and then an open dot as the two boundaries, line connecting between the two. And so the solution to this question, the graph of your solution, is what you see here in green. The way in which questions will get given to you may become sort of more complex, but the basic basics that I've gone through still hold. So with this question, we've got two inequalities here, and again, in terms of your set notation, what you're concentrating on, A is a set where X is an element of, and there's the inequality that's of importance, okay, and X is a real number. And secondly, B is a set where X is all the elements that fit the criteria of, and there again, there's your inequality, and again, it's telling you that X can be a real number. So we're going to concentrate on the bits that I've highlighted there and nothing else for the moment. So if we solve 7 being less than or equal to 10 minus 3x, we get x is less than or equal to 1. And then if we also take, that's set A, that's the solution to set A. And then for B, we've got the inequality 2 is greater than 4/3 minus 2x. And we get the solution of x is greater than minus 1/3. That's the set B values. And so now we're being asked to graph the solution set of the intersection of A and B. And that's basically exactly the same as, in a sense, that the same as we did the last example there with the two inequalities and the overlap. Okay, so again, you might want to represent each of these separately on a number line. You may not need to, but we'll just do that quickly. So we have a number line. You can notice I've actually adapted my number line to be quite broad because I'm dealing with a very small sort of area of the number line between 1 and -1. And I've plotted my two solutions. But the key thing is I want in between there, I want the overlap effectively. You can see here the overlap occurs from minus 1/3 up to and including 1. Now you don't need to draw the two initial parts. You might find it's easy enough just to put it together. At the end of the day, x is going to be greater than 1/3, and it's going to be less than or equal to 1. So what I'm doing here, my solution is simply a graphing of that double-ended inequality. And the idea of this sort of intersection is the idea of the overlap. If you think about, obviously, a Venn diagram, the overlap is where the two circles sort of overlap. And here on a number line is where the two number lines, sort of arrows, overlap.